Hi there, my name is Lars Sorensen. We're over here at CVC 2019 in Las Vegas. And at this computer vision conference, we're offering you small bits of video of just all the exciting things that are going on here. We'll have some people that submitted papers, we have presenters, we have keynote speakers. We'll have them all for you available on video here. And our next guest we're going to talk to is a machine learning engineer. We need those a lot because we have a lot of machine learning going on right now. Sebastian Niehaus from Icura Medical GmbH. So great that you are with us here. And we're going to talk about your work and your research just in a minute. I'm just curious how your experience with us has been so far.
It was really great. Normally, I only visit conferences with a focus in medicine. And in this case, I see a lot of other fields of application for machine learning, for computer vision, and it's very exciting for me.
Awesome to hear that. This is exactly what we aim for, to make all those new connections between all those columns. And so you're mainly in medical, you say. So then it also must be, maybe, is it difficult then, because you're connecting to people that have like more a mathematician background or more engineering background?
This isn't a problem for me, because my personal background isn't medicine. I only work in a company for medicine. My background is very unconventional for working in computer vision and for working in medicine. My background is business. I studied information systems and started with working in recommender systems, as you know it from Netflix, for example. We worked in fields like predictive maintenance, and then we started with image analysis. And from image analysis, we changed to medical imaging, and there I work now. So
that were the steps of your career.
Right.
Now, we have a lot of different people here from all those backgrounds. A lot of them would have like an interesting profile like you, bringing all your knowledge together to the piece of your research now. You already mentioned you're working on imagery and detecting objects within image. How does this connect to the medical field?
In medical, you have often problems where you have to detect anomalies, like tumors or interesting regions that could be everything, like white matter lesions.
Okay, so it's very wide,
and there you can set a bounding box or image segmentation, and in our paper we didn't apply that on medical images because our related work also didn't this, so we detected airplanes.
Okay, so that you especially for this research choose for an entire different aspect. Tell us a little bit about that, how you came up with that idea and how it worked out.
Okay, normally if you detect objects in images, you have one decision. You decide there's an object. But if you think about how you would decide where's an object, you won't do this like this. You set a bounding box, change the position, change the size, and we modeled the problem like this. We modeled the problem like a sequential problem, and changed the position of the bounding box, changed the size until we have the perfect bounding box. And I think this is very important to model problems in this way how we would solve it, because if we do this, we can more easily understand algorithms and how algorithm works, and I think this is very important.
So, but up till now, how would the usual approach would have been? Let's say the traditional approach.
You mean?
To detect those, because you're describing, you specifically chose for a different approach on that, and going for the outline box or and then so what would be more the traditional way of doing that?
The traditional way is more an extraction of features. We also did this, and then you classify the features and therefore the pixels. And then, based on the classification, you set the bounding box.
So, and your approach is totally different. I can imagine it also makes that people have maybe some critical questions on that. Did they have critical questions on your presentation?
Yes, but not really critical, because reinforcement learning isn't very common for this. And
Can I ask you that question again? You're just stepping more and more that frame.
oh, sorry.
Oh yeah. Be more here, I guess, right?
Yeah, that's better.
Yeah.
Okay.
Just go with that question again.
Okay, yeah, sure. We'll cut it there. No problem. So you're choosing a really new approach in your research, and I can imagine this might call for some critical questions from the more traditional way of looking.
Yes, but not really, because reinforcement learning to solve this problem is very unconventional, and the most people aren't familiar with reinforcement learning. They were really interested. I had questions all over the day yesterday for my approach, and a lot of people said, "Oh, I have to read your paper, and can I write you an email?" So very good feedback, but and also wondering people, but not very critical.
Not critical. They're mostly like, you could say, enthusiastic about maybe they can apply this to their own work.
Yeah.
Well, it's really good to hear that. And so you had nice response to your research. What will be the next step from here?
The next step is also work in practical, because I work in a company, and we are every time interested in solving problems in the real world. So we will apply this in medical data and also provide it for customers. Yeah.
Okay. Well, great to hear just and to have a little bit of your time available to elaborate on this. I want to thank you so much for being with us here at CVC. Well, did this video inspire you as well? Don't keep it to yourself. Share it. And if you want some more video content that we've created at the Computer Vision Conference 2019 in Las Vegas, you can check out all the videos just by subscribing. We'll make them available to you. And please consider joining us for one of our events coming to you in a place. Check out the dates on our website, and we'll be back to you soon. Thank you for watching.